Hey guys, Mr. Betts here. I want to take a look at a couple examples of improper integrals that tie in with some other integration techniques that we've talked about recently. So the first one here, the first thing I'm going to do is I'm going to rewrite this using a limit because I see this infinite upper limit and I know it's an improper integral. So I'm going to say the limit as a approaches infinity of the integral from 1 to a of x times e to the negative x squared dx. Now, the next step is going to be to evaluate the antiderivative of our integrand. This is a product, so we might be thinking integration by parts here. However, notice that the exponent here is x squared or negative x squared, and the derivative of that is going to be an x to the first power, which we have here. So we can actually evaluate this antiderivative using substitution. So I'm going to do that. So I'm going to say u equals, and I'm going to choose negative x squared. It actually doesn't matter if we choose x squared or negative x squared. We're going to end up with the same answer, but it's just going to look a little different in our work. We got du equals negative 2x dx, and we've got then dx is equal to du over negative 2x. So rewriting this, keep our limit on here. A is approaching infinity. I'm going to leave my limits off. Remember, when I change the dx to du, I need to change my limits also. So I'm going to hold off on that. So I've got my integral x times e to the u. And then dx is going to get replaced by du over negative 2x. And now I'm going to change my limits because I did change the dx to a du. So when I plug 1 in for x, I get negative 1 for u. And when I plug a in for x, I get negative ax squared. Not ax squared, sorry, negative a squared. So my limit is getting a little more complicated, but it's not going to cause any issues here with our evaluation. I can cancel the x's. I can take that negative 1/2 out front. And so we've got a fairly simple integrand now to evaluate. So let's do that. So we've got the limit as a approaches positive infinity of negative 1/2. Probably need parentheses there with a negative out front. So the antiderivative of e to the u is e to the u, evaluated from negative 1 to negative a squared. So then we're going to have negative 1/2 e to the negative a squared minus e to the negative 1. And we're going to evaluate. So evaluating this, when we plug a infinity in for a, this is going to be negative infinity. So we have 1 over e to a big power is going to be 0. So this term goes away. And so what we get is negative 1/2 times negative 1 over e. And so this is going to be 1 over 2e. That's it. Nice and easy. Okay, this one's kind of similar. We're going to have to tie in an anti-differentiation method that we've learned recently. So let's start, though, by handling the improper integral. So we'll have the limit as, let's say, c approaches infinity, the integral from 2 to c of 3 over x squared minus x dx. Now, this one, we can't use substitution. That won't help us because if we say u equals the denominator, then we're going to need a 2x minus 1 in there to handle our derivative. We can't use integration by parts with a division. We can't use a natural log because if we said that the antiderivative was 3 natural log of the absolute value of x squared minus x, taking the derivative to get back to this would require the chain rule, and we'd have a 2x minus 1 in the numerator. So we've got some problems there. What we can do, since we have a quadratic in the denominators, we can rewrite that integrand using partial fractions. So what I'm going to do off to the side is I'm going to rewrite this as 3 times x minus 1, 3 over x times x minus 1. So partial fraction method here, I'm going to say a over x plus b over x minus 1. Adding these fractions with a common denominator, we're going to have a times x minus 1 over, plus b times x, all of that over x times x minus 1. And then we can choose some x values to solve for a and b. So if x is equal to 1, then we're going to have 3 equals b times 1. So 3 equals b. If x is equal to 0, we're going to have 3 is equal to negative a, and a equals negative 3. So what we can do is we can rewrite that integrand. So we're going to rewrite the entire expression, including the limit, as, let's see, a is negative 3. So negative 3 over x plus 3 over x minus 1 dx. Now, I am done with my partial fractions. I would definitely want to leave this on an assessment that was going to get graded. Oops. But I do want to give myself a little room, so I'll just squeeze it down. Might be a little too small. You get the idea. I want to keep my work there, but need to get it out of the way. And now we're going to evaluate from there. So now we've got the limit as c approaches infinity. So the antiderivative of negative 3 over x is going to be negative 3 natural log of the absolute value of x, evaluated from, well, we'll evaluate the whole expression, never mind, plus 3 natural log of the absolute value of x minus 1. And then that entire expression is going to be evaluated from 2 to c. So we've got the limit as c approaches infinity of, so let's plug c in first. It's going to be kind of a big expression, but then when we evaluate the limit, it'll clean up a little bit. So negative 3 natural log of c. C is a positive number, so we can get rid of the absolute values there, plus 3 natural log of c minus 1. And then, so that's plugging c in. And then plugging the 2 in, we're going to have negative 3 natural log of 2 plus 3 natural log of 1. Okay, so let's evaluate our limit now. So as c approaches infinity, let's simplify this expression first before we try to evaluate this limit. So we have got a lot of stuff going on here, but we're going to have, let's see, this whole thing right here is going to be 3 times the natural log of c minus 1 over c. So that's using log rules. Remember, if you subtract a log here, you can divide by the log and the inside of the log. So this is going to be the limit as c approaches infinity of 3 natural log of c minus 1 over c. And then this expression, if we distribute that negative first, is going to be, well, this is 0, so it's just 3 natural log of 2. So let's think about what happens as c approaches infinity. So c is getting really big. So this part right here is going to approach, well, 1, because we have 1c over 1c. The c's are going to dominate. So we have the natural log of 1, 3 natural log of 1, that's going to be 0. So the c minus 1 over c approaches 1, and the natural log of 1 is 0. So this whole thing here is 0, and we get 3 natural log of 2. Which, if this were a multiple choice question, you may have to match up to the natural log of 8, because that is the natural log of 2 to the third power. So we can take that 3 as an exponent. If this were free response, we would need to simplify that log to evaluate this part, but you would not need to evaluate this one. Whew, that was fun.